Welcome to Laserhuis, where laser engraving becomes simple, practical, and a lot more creative. In this video, we walk through a complete workflow, from finding a suitable engraving image, to preparing it for laser work, to checking the final result inside LightBurn. The goal is not just to make an image look good on screen, but to prepare it in a way that can actually engrave cleanly on real material. We start inside the LaserMaster learning environment, where everything is organized around laser engraving courses, materials, tutorials, projects, and practical examples. This is important because good laser results do not come from settings alone. They come from understanding the material, the image, and the preparation process before pressing start. The first step is choosing the right image. For engraving, not every picture is ideal. We are looking for an image with clear contrast, strong subject detail, and enough separation between the background and the main object. A good engraving image should already have structure, light, shadow, and visible texture. The better the source image, the better the final engraving can become. Here, we browse through the available image resources and open a high-resolution artwork. The examples show detailed black and white illustrations, which are very useful for laser engraving because they already contain strong lines and tonal depth. The goal is to select an image that can survive the conversion to dots, patterns, and engraving contrast. After selecting the artwork, we move into the Laserhuis image preparation tool. This is where the real work begins. The original image is shown on one side, while the processed engraving preview is shown next to it. This comparison is very important. It allows us to judge immediately whether the image is becoming too dark, too light, too noisy, or too flat. Before changing the artistic look, we first check the size and DPI. This step is often underestimated, but it is critical for laser engraving. The physical size of the design determines how large the engraving will be on the material, and the DPI determines how much detail is packed into that area. A beautiful image at the wrong size or resolution can give poor results, so this step should always be checked carefully. The tool also analyzes the image and gives useful guidance. It detects characteristics such as contrast, detail level, and the kind of material that may work well. In this case, the image has fine detail and a darker, artistic style, so the preparation needs to preserve texture without turning everything into a black block. Next, we enter the dithering stage. Dithering is one of the most important parts of preparing an image for diode laser engraving. A laser does not engrave smooth gray in the same way a screen displays it. Instead, we need to translate tones into dots, patterns, or controlled black and white structures. This is what creates the illusion of gray, depth, and detail on the material. Different dithering methods can completely change the final look. Some methods give a softer photographic result. Others create sharper contrast or a more graphic engraving style. In the video, we test and adjust the processed preview until the hummingbird remains clear, the wing detail stays visible, and the background does not overpower the subject. The preview is not just a decoration, it is a decision tool. Every slider change affects the balance between black areas, white areas, and fine detail. When the processed version becomes too dense, the engraving can become muddy. When it becomes too light, details may disappear. The best result is usually found in the middle, strong enough to engrave with impact, but controlled enough to keep the subject readable. We also adjust settings such as dithering strength, dot size, line spacing, and pattern behavior. These controls influence how the image will translate to the laser. Smaller dots can preserve more detail, but they may require better material control. Stronger dithering can create more contrast, but too much can destroy subtle shadows. That is why the original image and processed preview are always kept side by side. Once the image looks ready, we export it as a PNG. This is the bridge between image preparation and the actual laser software. The goal is to export a file that is already clean, already sized correctly, and already converted for engraving. That way, LightBurn does not need to fix the image afterwards. LightBurn can simply place it, scale it, and run it with the correct material settings. Now we open the prepared image in LightBurn. This is where we verify the real engraving layout. The image is placed on the workspace, and we check its physical dimensions. The design is positioned on the grid, scaled to the intended size, and inspected visually before sending anything to the machine. Zooming in is a very useful step. From a distance, an engraving preview can look perfect, but zooming in reveals the actual dot structure and the level of detail. Here, we can clearly see how the hummingbird is built from controlled black and white texture. The feathers, body, wing, and background remain readable, which means the preparation has kept the most important details intact. Inside LightBurn, the material library and image settings are checked as well. The selected material profile matters because wood, slate, ceramic tile, and coated materials all react differently to laser energy. The same image can need different inversion, power, speed, and scanning behavior depending on what it will be engraved on. We also check the image mode and engraving parameters. For this type of prepared artwork, the image settings need to match the way the file was generated. If the file already contains a clean dithered pattern, we do not want to accidentally destroy it with unnecessary extra processing. The goal is to keep the exported structure as stable and predictable as possible. The video also demonstrates why material presets are useful. Switching between materials changes the way we think about contrast and inversion. A dark material may need a different approach than a light material. Slate, ceramic tile, walnut, and coated metals do not respond in the same way. That is why a good workflow always connects image preparation to the target material. After checking the result in LightBurn, we return to the Laserhuis tool and continue refining. This back and forth is normal. A good laser workflow is not just one click, it is a controlled process. Prepare, preview, export, inspect, adjust, and confirm. We test options such as grayscale, invert, edge detection, line art, erosion, dilation, and material presets. These controls are powerful because they allow the image to be adapted to different engraving styles. For example, edge detection can help create a more line art style result, while grayscale and dithering preserve more of the photographic look. Invert is especially important when working with dark materials or materials where the laser creates a lighter mark. The final preview shows how much control is possible before the laser even starts. We can see the hummingbird as the original artwork, and we can see the processed result as a laser-ready interpretation. This gives confidence before wasting material. Instead of guessing, we are making decisions based on a visual engraving preview. This workflow is exactly what makes laser engraving more predictable. Start with a strong image, prepare it with the right size and DPI, choose the right material behavior, apply dithering carefully, export a clean PNG, check everything inside LightBurn, then engrave with settings that match the material. The big lesson is simple. Great engraving is not only about laser power, it is about preparation. The image, the contrast, the dithering, the DPI, the material, and the software settings all work together. When those steps are controlled, the final result becomes sharper, cleaner, and much more professional. With Laserhuis, the goal is to make that workflow easier to understand and easier to repeat. Whether you are engraving on wood, slate, ceramic tile, or another material, the same principle applies. Prepare first, preview carefully, and only then send the job to the laser. This is how you turn a normal image into a laser-ready engraving file with control, confidence, and repeatable results.